Okay, let's take a look. This is chapter 6. On Monday, we will do a review for the test. The test will be next Wednesday. I will have the review uploaded, like you can do a practice exam for yourselves. Hopefully tomorrow, but definitely by Friday. And then we'll go over that practice exam on Monday and show you all the solutions and stuff. So you'll have an idea. And if you've talked to anybody that's taking my classes, I don't dick around. What I put on the practice exam, that's what the types of problems you can expect on the actual exam. I hate teachers that here, this is what I want you to know, and then they test you on completely random shit. Don't like it at all. So this is Math 207. We're looking at chapter 6. And it's, what is the official name? The official name of this chapter is statistics. So part of the chapter is knowing how to read different types of graphs. So this is a pie chart. If you want to try to sketch it, you can. I pulled this from the book. I doubled all the numbers though, so it's slightly different. But I'll give you a second to write it down. In fact, yeah, we'll just do that. Let you do that. And then we're going to work on some questions on it. And talk about reading it. It's Bob Ross murder. That's fucking great. Like, there's no way that could be true without me having heard about it. If it's true, then he lives in Vermont, because his landscapes always look like spring and summer in Vermont and New Hampshire, and that we were there in May or June, and oh my God, it's so gorgeous up there. It's like, yes, I need to buy a home. When I have a lot of money, I want to buy a home here. And then it's like, oh, but it's buried under snow 4 months of the year. It's just 80. Social Security is 80. $24, $130, $260, and $706. Okay, now we're still going. Give you a little longer. Y'all knew who Bob Ross was. I guess I was wrong when I told Mason you should know who Bob Ross is. He emailed me today and was asking me a question. He signed it Bob Ross. And I laughed. Okay, so pie charts come in two flavors. They either kind of show the amount or they show the percentage. A good chart will show both, but usually a lot of them don't. So a lot of times you'll have a pie chart. You need to be able to look at it and figure out what's going on. If a section looks like it's more than half of the circle, it probably is. Because pie charts are deliberately designed to start from the center. So if you can take a straight edge, I won't use my book right now. Well, I'll try. Let's see that. And you can put it over and like take home. It's covering half the circle, but then it's got some more right there. This is clearly over half the circle, which means it's over 50%, which hopefully is the case because it is your take-home pay we're talking about. Other than that, you can kind of like if it only does something like this, that's going to be 25% of the circle. So if it's smaller than that, it should be less than 25%. But the easiest way to go about finding it is if they don't give you a total of how the values are, add up all the values. And in fact, let's make sure that they didn't lie to us. Let's just add up the values here and see what we get. So I'm going to add up 706. Plus 80. Plus, I wish I brought my other calculator. 124. That didn't happen. Let's try that again. 124 plus 130 plus 260. So 1,300, and that's what it says. And then we can use that information to start answering questions like, what percentage of the check was take-home pay? Like, how much of this person's check how much or what percentage, we know how much, of the check was take home. Now, if you've never had a job and you don't know what I'm talking about, you will get a job, and unless it's under the table, you will work hard for your money. And then every motherfucker in the world wants a piece of your check. The state wants a piece of the check. The federal government wants a piece of the check. Federal government will take multiple pieces of your check. One will call income tax. Another will be Social Security, which is supposed to be a retirement, which may or not be there. May or may not be there when you guys are old enough to actually use it. Insurance might be taken from there. There's other ones that are taken. So you don't get 100% of your check when you work. Often it's a good 30% lower, if not higher. So let's figure out how much this person took home. When we want to do a percentage, remember we can make a fraction and just do division. And so we want the total on bottom and the amount in question on top. For us on this problem, that is $706 divided by $1,300. And if I do this in a calculator, I get 0.543. I'll just leave it there. 0.543. Now that doesn't give me the percentage. At least this gives me a proportion. So maybe writing percentage was the wrong word. This is the proportion. If I want a percentage, I just need to multiply it by 100%. Which is the same, remember, as shifting the decimal place right twice. But I will show you on my calculator, answer times 100. What happened? 100. And I get 54.307 or 54.3%. So it's a little over half their check. And we can check this on like each of them. How much? This doesn't even show state tax being taken out. So this is bogus. Let me let you guys try it. Figure out how much. Figure out what percentage was federal income tax. So if we want to figure it out, we need to figure out what portion is federal income tax and then divide it by the whole. The portion that's federal income tax is $260. And if I divide it by the whole check,
$0.158.
and if we turn that into a percentage, we get 15.8%. Take-home pay is usually called net pay. Just some fun info for you. And pre-take-home, like the actual earned part, is called gross pay. Just, yeah. Did you get something different? All right, let's check the math.
Yeah, that's what I got too.
Is this what I get for trusting? Yeah, I got 0.2. What are you over here fucking with me, Bertha? What is going on?
Oh, I did 206 instead of 260, so I'm not listening.
You trust a student and she just throws your ass under the bus.
Sorry. I'm fine.
Thank you for catching that. And saying something. Too often students will let me put the wrong shit up and just let me go with it. And think they did something wrong. They're like, this is just too straightforward to do this wrong. Let's take a look at another one. You guys are gonna be drawing it for a while, so let me put it up there for you. So these are bushels of wheat. And I will zoom in for now. And then I'll zoom back out. So there's 4%, 10%, 36%, and 50%. I'll have you know, I tried to print these out so I could give you guys copies of the graphs. Look at the shit they pulled. I'm like, you know, this is a fucking textbook for teaching, right? All right. So there's 2.3 billion bushels of wheat. I don't know how much a bushel is. It sounds like it's either a very like a basket or it's a lot. I suspect a bushel is a lot. Is anyone in like the ag program that, do you have any idea how much a bushel is? Like, is it a weight base? Is it a volume base? Feels like it should be a volume base. How much is a bushel? Let's learn some fun shit today. The same unit is called the board foot. What the fuck?
60,000.
Oh, that's a good amount.
Also, it is weak.
Acre foot, gallon, quart. It's a measure of volume. There's 8 bushels to a gallon. Dry. In terms of liquid, it is 9.3 bushels per gallon. There's no way that's 60 pounds. There's no way that is 60 pounds unless it's like a gallon of lead. The other way, it's a lot of it's a volume of stuff. So the real question is, like, they give us percentages, but maybe we wanted to know like how much was actually used. So maybe let's figure out how many bushels were consumed. In general, not just by humans. So we have 2 approaches we could do. We could add the percentages first, or we can just figure them out separately. I'd say we do them separately so we can get an idea of what they are. So like the US consumption says 36%. If we want to calculate how much that is, we need to change this back to a decimal by dividing by 100 or moving the decimal point left twice. Which makes this 0.36. And then we're gonna take that 0.36 and we're gonna multiply it by the amount. Times 2.3 billion. Oh, I need to zoom out a little bit. And this is in terms of billions. So if we have that, billions is like 1 billion is, let's see, that would be 1 million, that's a billion. So if we multiply by that, we're really shifting the decimal place 9 places. There's 9 numbers, 9 zeros here. If I want to turn this into a number without the billions in it, that is 828 million bushels. That was for people. We can do the same thing for the livestock, but we don't need a calculator when we do 10%. A 10% shift is just shift the decimal by 1 decimal place. So 10% takes the decimal and moves it left once. This would be 0.23 billions. And if I make that follow the other one, that is going to be 230 million bushels for livestock. And if we wanted to find both, so for both, we just add them. We have the 828 million plus the 230 million. And we get 1,058 million. Which should be 1.058 billion. So let's do a little bit more with this. I'm going to use the same graph. Let's say 1 bushel of wheat makes 42 pounds of flour. After we mill it. So maybe 60 pounds isn't too far off for the right product. That's got to be wrong. I thought maybe 1 bushel was 9 gallons or 8 gallons, not 9 bushels per gallon, but 9 gallons per bushel. That's probably more like it. It doesn't make sense for them to say like, make a bushel like the size of 2 cups. Doesn't make any sense. It's gotta be, that website's backwards. That's what I get from looking at that website. Let's figure out how much pounds of wheat humans used. Now, we already figured out that humans ate 828 million pounds or bushels. How do we figure out the weight here? What do we do? I have a ratio of 42 pounds to 1 bushel. Remember, we can use our conversion bridges. We're trying to get rid of bushels, so we'll put bushel on the bottom. We want pounds, so we'll put pounds on top. And we'll figure out what 828 times 42 is. I'm getting 34,776 million pounds, which is 34.776 billion pounds of wheat. All right. Next one, I'll put some questions up. We're going to do these questions on the next graph. We're going to find the percent increase in oil consumption. That's what the next graph is about. Let's do from 1995 to 2010. And then maybe we will also guess which 5 years had the greatest increase without calculating. You can see my text? I was totally in my office just doing nothing. Well, I wasn't doing nothing. I was trying to, this is fun. I tried to print out some graphs from the book to use in here. They made sure I can't use this for anything. So we're about to put it up on the screen from the textbook. This is Professor Beret, for those of you that haven't met him, he's the other math teacher in Tulare.
With more tenure.
They don't care about that.
More
He's less,
experience.
more experienced, but a lot less cool.
Sure,
We could do a survey.
in your class, that sounds biased. At least I remember my meetings.
And it wasn't on my calendar for the first time. You know, like I was just telling him about it. Normally, I get the calendar reminder. I'm like, I didn't need the reminder. I remember. And then and this time I'm like, nope,
I
completely
sent
forgot.
an invite too.
You did?
Yeah,
I must have not have clicked accept.
see, you don't want to
That's
do
my
that.
bad.
Good luck with your schedule.
I haven't taken the classes yet. What are you talking about?
I just got through writing the spring schedule.
Yeah. I still haven't picked them. I don't have to pick them.
This is everything, everything you did.
Oh. You did.
I
I know.
Pretty close to the
If
same.
you didn't, I know Luann did.
It's close to the same.
Yeah, I figured that.
Close to it.
See ya. All right, let's throw that graph up. We're doing the bottom one. Can I? Nope, I don't want to search. Can I make it bigger? There we go. Look at this clever guy. Figured that shit out. All right, so we want to find the percent increase in oil from 1995 to 2010. So maybe we need to figure out what those values are. So if you're not familiar with reading a bar graph, there's two axes they're called to look at. There's usually numbers, but they're not always numbers. Like the graph above didn't have numbers. But the thing that's next to the bar is usually the category. In this case, the category is the years listed down below. And then the bar will be a certain length, and the other axis, the other line, will give you figures to look at. And like, presumably, if you have a very good straight edge ruler or something like that, you can draw a line connecting this 60,000 to that right there. And if we did this 66,500, we drew it over, it would hit somewhere between the 60 and the 70 at the right percentage distance apart. So we want to figure out like what went on between 1995 and 2010. So we need to look at the values we have for 1995 and 2010. 1995 is this column. Oh, I can highlight. And oh, well, let me highlight again. Dirty. We highlight. Yeah, I don't need to fuck shit up. And then, so the 1995, I'll write it on the paper real quick, is 66,500. And if we look at 2010, 2010 is 84,000. So now that we have that information, we'll come back over here and look at it. If we want to find the percent increase, we got to figure out how much it went up. We have a couple ways we can do this. We can just figure out the overall percent increase and then subtract 100% to figure out what the actual increase is. Or we can figure out what the difference is now and find the increase that way. So I'll show you both ways. The first way I was saying is do the 84,000 over 66,500. And we're going to do this in a calculator. divided by 66500. And I'm getting 1.263. If I turn this to a percent, it's 126.3%. If we want to find the increase, we deduct it that 100%. Because the 100% is just the 66,500. We're left with 26.3% increase.
Why do you deduct the 100%? It's fine.
Because we just want to know what percentage the increase is, and the increase doesn't include the 66,500. If I show you the other way, it might click fly. So 66,500 for 1995, it goes up to 84,000. Let's find out how much it went up by subtracting this. It's 17,500. Okay, that is the increase in oil. But we want a percentage, so we're going to divide it by the 1995 amount over the total in 1995.
Why?
And we get 0.263. And if we turn it to a percentage, we get that. Does that make sense? Now, is it one of the ways is figuring out how much the increase is. This is like the equivalent is like looking at sales tax. You can either take the total and add 8% sales tax, or whatever sales tax is, or you can do 1.08 times it to get the sales tax. It takes some work, it takes some practice. Let's go look at the other question. Which was look at the graph and try to guess which one had the greatest percent increase. So the way I would go about doing this is first off, I'm looking between them. I'm looking at a pair of columns. I'm going, how much did it go up? And I'm trying to compare it to other columns. And like, so this one went up an okay amount. This one didn't go up that much vertically. This one seemed to go up quite a bit, and this one seemed to go up quite a bit. That one, not so much. So maybe I could see the difference here. 60,000 to 66,500. This is 6,500 bigger. These numbers are a little easier to do. 70 to 77 is 7. And 77 to 84 is also 7. So the years 2000 to 2005 went up 7,000 each. And then 2005 to 2010 went up 7,000 each. So if I were going to guess which one had the bigger percentage, I'm going to look for those amounts and go, which one started with the smallest amount? Because going from 70,000 to 77,000 is a specific percentage bump, and then this is a specific percentage bump. These two are pretty close. I think you'd be safe in guessing either one, but I think the 2000 to 2005 is got the higher increase because it started off with a lower amount, but it still increased by just as much. It's like the equivalent of saying you start off with $10 and you made $10 more, so you're at $20. Or you started at $100 and you made $10 more, and you're at $110. In both cases, you made $10, but the one where you start out with 100, another $10 isn't that much. The one where you start out with 10, where you start with only 10, not 100, you've doubled your money. So I think it's the smaller one there. There are some other graphs they want us to look at. We're just gonna take a peek at them. There's something like this. These are line graphs. So I'll ask you to take a look at line graphs and let's just eyeball these and figure out what's going on. So again, these have two axes and it looks like both sets have numbers. On the bottom, it says volts. And on the left side, it says amperes or amps. And they got little hashtags. Then they've got longer hashtags and shorter hashtags, kind of like a ruler does. The smaller hashtag should be the halfway point. So like this right there should be about 1.5. This right here should be about 3.5. Right here, halfway between 60 and 70 should be, or 60 and 80 should be 70. And so we can look at it and go, and there's two different lines. One is a 25 ohm resistant line and the other is a 10 ohm resistant line. So we can look at it and ask different kinds of questions, like how many amps of current are produced by 50 volts when the resistance is 10. So if we look at this first question right here, it's saying when the resistance is 10 ohms, that's the symbol for ohms, would they want us to look at this purple line? And then it says how many amps of current are produced by 50V or 50 volts? Well, we got to come over to the 50 volts and we got to try to go straight up. If I go straight up, it looks like it's hitting right about there. Right there would be 5 amps. How many volts are needed to produce 2 amps of current when the resistance is 25 ohms? The next question. They want us to look at the 25 ohm line, which is the blue line now. And we're going to start at 2 amps and try to figure out the other lines, or the other parts value. So 2 amps is right here. I'm going to use the top of my line, the top of my cursor to move over. I'm going to try to keep it straight flat. That looks like if I come straight down, it's about 50, right? It's looking like 50 volts there. And it says, how many volts are required to produce a current of 3.5 amps when the resistance is 10 ohms? So the 10 ohm is the purple line again, and we start off with amps. So we're going to start on the amp line. We're going to move over and see where it hits the purple line. And then try to come straight down. Looks like maybe 30 volts. Maybe 35. It might have been a little bit above. It's a little hard to, without, these are terrible graphs. A good graph would have like background, like grid paper kind of thing, so you could get a better estimate. Another type of line graph is this, where they've got 2 lines. So the blue line is motor gas, and the blue line with the squares is motor gasoline. The red line with the triangles is jet fuel. And it says this figure is petroleum products supplied by different types in the US by thousands of barrels. So this isn't just 1,631, it's 1,631,000. And so they'll ask questions like, what year was the motor gasoline supply at this value? Well, I don't see this value, this 8,796,000 on there. But if I do it in terms of thousands of barrels, I need to look at this in terms of thousands of barrels. So I could cut it off right here. And go, what's the number in front? 8,796. That is this button right here. That's over the year 2006. So sometimes you got to read the details on the figure to get a little bit more information. What 5-year period saw the greatest percentage decrease in jet fuel? Without doing the calculation, we're looking for the line that goes down the most. Looks like this one goes down a little bit more than this one goes down. This looks sort of flat. It looks like this gap right here is the biggest decrease. But we could go through and do percentages and find each one if we type up, calculate the percentages. What else do we got to talk about today? Oh, okay, enough with graphs. Now I can switch to the bigger, look at me from far away pins. Oh. So let's do that. Did you need that up on there? So we're also looking at the arithmetic mean. This is also known as the average. The way they will show you how to do this, they'll give you one notation, and I'll show you what it means. They will say this. So maybe I should give you some numbers. 1, 4, 9, 16, 25. Okay, so those are 5 numbers I'm going to use. What this means is this E right here, it looks like an E. This means it's called sigma. And it means add them up. The N means total number of entries or values. So if I were to give these numbers, I could say this is the first number, this is the second number, this is the third number, this is the fourth number, this is the fifth number. The I is used to represent what number it is. So this would be X1 like that. That would be X2. That would be X3. That would be X4. That would be X5. These subscripts, these numbers that are below the letter, just tells you which number it is in the sequence. So what this thing right here is saying is add up all the numbers in the sequence and divide by the total. Not the total of the numbers, but the total number of entries there is. For this problem, We are going to add up 1 plus 4 plus 9 plus 16 plus 25. The total number of entries, I've numbered them, there are 5. I'm going to divide by 5, so n equals 5 here. Let's see, I've got 10 and 20 is 30, plus 25 is 55. I got 55 on top, over 5 on bottom. I get exactly 11. So the mean or average is 11. Okay, let's look at some more. Next, we're going to use the same 5 numbers. I'm going to leave them where I'll redraw them. Next one we'll talk about is the median. And we'll have those same 5 numbers. Median, if you drive, you've heard the word median before, it's the middle of the road. That strip where there's bumps or the line or something. Median means middle. Which means the numbers must be sorted. Either high to low or low to high. So if they're not in order already, you have to sort them and put them in order. Because otherwise you can't find the middle. You don't want to just go with the middle of the current arrangement because it might not be the middle number. Then there's 2 ways of doing it. If n equals odd, it's just the direct middle. If it's the numbers are too big to determine, one way of finding out which one it is doing n plus 1, whatever that value is, and dividing by 2, and going to that term. So in the example I gave, n equals 5. 5 plus 1 over 2 is 6 over 2, which is 3. I'm looking for the x3 term. The x3 term is the one in the 3rd position. So the median in that list is 9.
I just like, got 1, 5, 4, 6, 16.
That is definitely what I would do when there's a small list.
Yeah.
So, as she was saying, like, the other way of doing it is just cross them off one at a time. Starting on the outside is working in. I'll cross off the 1 on the left and the 25 on the right. I'll cross off the 4 on the left, the 60 on the right. When I get to the center, bam. That is definitely what I would do. I was getting ready to go there. If you've got like 620 some entries, that's a pain in the ass. It takes a long time to do. You'll probably, if you had that many entries, you probably have them in like Microsoft Excel or a Google Sheet, and it will tell you the row numbers. So you can easily just go to the bottom, like, so this is for large data sets. In like Excel. It will tell you the number of rows just by going to the bottom of the list. Go to the bottom of the list and you'll see how many rows there are. We'll call that N. So at that point, if N equals odd, add 1 to it, divide by 2, you'll get some value, and you can just scroll to that value, scroll to that row in Excel. I would definitely never count these by hand when there's that many, and when there's very few, I would do exactly what you said, cross them off. It's a little bit different when it's even. So let's take a look when N is even. And I'll just add another number. So in this case, N equals 6. So let's try your cross-off method. The 1 goes with the 36. What? We left off the 2.
No.
Oh yeah, we're left off with 2 of them, right? So I can't cross them both off. So what we do is we take the mean or average of these 2. We're going to say 9 plus 16 divided by 2. Which is 25 over 2, which is 12.5. If you're doing it with a really, really, really big data set like the Excel, you're going to average the 1/2 N number and the 1/2 N plus 1 number. We can see that with the numbers we have here. The 1/2 N is 6, so 1/2 of N is 3. And 1/2 of N plus 1, 3 plus 1 is 4. So the 3rd and the 4th number. That's the 3rd number and that's the 4th number. But you would be going down to those rows in Excel, grabbing those 2 values in those 2 rows and finding the average that way.
So. 16.
No, and the total was six, n was 6 was even. We can't just pick the last one. We got to average the two. So we add the two up and we divide by 2. And so the mean or the median doesn't even show up on the list. If you'll notice that 12.5 is like somewhere in there. It's not on the list. So the median's on the list when n is odd, but it's not on the list when it's not. It could be. But usually if it's on the list, it's only because the two numbers are the same. In fact, that's the only time it's on the list. The third one that we're going to look at is called mode. Mode is just the most common answer. So let me just throw some numbers out. This is a lot easier when they're in order. To figure out how many there are. You can just count them up at this point, but we really need to just figure out how many each number has. There's only 117. There are 3 18s. There are 2 19s. There's 120, 122, and 123. The mode is then 18. It has 3 values. Or the most values. I don't know how much of this stuff is really useful to you guys. I'm going to cover some more of it now. Another value is called a measure of central tendency. These have all been measures of central tendency. Where's the middle? We also look at what's the actual name they like to use. I'm going to give you the name they say. Zoom back out. That was above. Below is called measures of dispersion. I do not know why I brain farted on this. I know this stuff. I teach stats all the time. So measures of central tendency was above. Measures of dispersion, we're going to look at the range. We'll look at quartiles and IQR. And we'll look at standard deviation, which is the one you're going to probably like the least. the range is just the high minus the low. On my data set above, that is, let's use a different color. The high is 23. The low is 17. So the range is 23 minus 17, which is 6. This tells us how far apart is the maximum of all the values. Saying that a little bit funny, but it kind of like 17 to 23, they're not that far apart, they're 6 away. If I had that on a test, like if the scores on a test and I had a range of 6% on the test, it means everyone did roughly the same. We might have had a 96%, or we might have had as low as a 90, but everyone was pretty close. Sometimes they're quite a bit different. So an example of why we look at the range, I'm going to give you 2 scenarios and we'll do the mean real quick on them. Where is? So data set 1 is going to be 48, 50, 52. Data set 2 is going to be 30, 50, 70. In both sets, n equals 3. If I want the mean of data set 1, that means I've got to add up the 48 plus the 50 plus the 52. And then once I've done that, I'm going to divide it by 3. You should get 50 if you do this in a calculator. If I do the same thing with data set 2, I've got 30 plus 50 plus 70 divided by 3. And we also get 50 for the mean. You got your calculator out? Go ahead and confirm that for me.
Yeah.
So,
For me,
what? For mean 1 is 50. You should get 50 for mean 2 as well.
listen,
If you don't have parentheses, make sure you hit equal after you do the adding and then hit divide by 3. Okay. So they both have the same mean, but we can look at them and go, these are very different, right? If I look at the ranges, the range on data set 1 is the high minus the low, which is 4. I do the range on number 2. I have 70 minus 30, which is 40. So these ranges, the range shows how spread out the answers are. All right, so this is these are called measures of dispersion. The range is a measure of dispersion. There's another one. I don't think the quartiles and interquartile range is that important to you, so I'm gonna not do that one, and I need to change the homework tonight before. Don't anyone start the fucking homework yet on chapter 6 until I do an announcement. I gotta go home and delete those problems. Otherwise, you're gonna have to do them. Standard deviation is the other one. It's usually abbreviated like that. It's standard deviation. Deviate is like, how different are you from the normal? And in terms of math, we say from the mean is different from mean. That's the idea of what standard deviation is. It's got a formula. Thankfully, the problems that you have in the homework only have like 4 or 5 numbers. You guys ready for the formula? So standard deviation, we're going to do, this is our formula for it. We are going to take each xi value. We're going to subtract the mean. The mean is listed like this. X bar means mean. I don't know why I didn't show you that earlier. I meant to. We're going to subtract them. We're going to square them. Then we're going to add them up. Then we're going to divide by n minus 1. And then we take the square root. Right? So maybe if I write a little list, this might be helpful. Subtract mean from value for each one. Square that number. Add all the squares up. Divide by n minus 1. Take the square root. So when you guys have that list written down, we'll do an example. We'll do that 1, 4, 9, 16, 25 we had earlier. I will tell you this, I do need to show you how to do this. That doesn't mean I have to test you on it. So I'd like you to do the homework problems that have standard deviation, but I promise you there's not going to be a standard deviation problem on the test. Okay?
And we're gonna take that test in the class?
Yeah, we'll be in class. And I will make a practice exam, so, and it should have it up, hopefully I'll have it up tomorrow. If I don't have it up tomorrow, I'll have it up Friday. So you can try it over the weekend. And then on Monday, we will go over the practice exam in class so you can see what all the answers are. And then we'll have the test on Wednesday. So let's look at doing this example with the numbers we had before. The 1, 4, 9, 16, and 25. That was our data. If you recall, we calculated the mean for X bar was 11. I think it was 11. Let me double check. Sounds right, right? Damn, I wrote a lot of work since then. 11. So, pro tip, when you're doing on the homework, make a little table. So I'm gonna make a table. I'm gonna do X or XI. I'm gonna do XI minus X bar. And I'll leave a little room to show that operation. Then I'm gonna do XI minus X bar squared. I guess I don't need all those columns. I only need 3. So my numbers were 1, 4, 9, 16, 25. Maybe I'll use alternating colors so they stand out a little bit better. That might not go down far enough. So XI is 1 minus 11 is -10. Four minus 11 is -7. Nine minus 11 is -2. Sixteen minus 11 is 5. And 25 minus 11 is 14. So here, what I'm doing, that was XI minus X bar. If I want to square that, -10 squared, if you put that in the calculator, it gives you 100. And then we're going to square the -7. -7 squared gives us 49. All of your answers, when you square them, should be positive. The square kills all the negative values. -2 squared is 4. Five squared is 25. And if, I'm gonna guess you probably need a calculator for some of these at some point. I happen to know the squares of all these. 14 squared, I'm pretty sure is 196. But that one you might want to check if you got a calculator out.
Yeah, that's right.
That's right. Okay, so now we have all the squared numbers. That was step 2. I squared the numbers. Now I need to add up all of these squares. So I need to find this value and I add them all up. Let's see, the 4 and the 196 make 200. Then I add another 100, I got 300. 349. And 25 is going to give me 374. Then we had to divide by n minus 1. You probably would have added these up in a calculator. I'm lazy. Physically lazy, mentally I'm not. I can add that up in my head if I put a little effort into it. But I want to turn on the calculator and try to fat finger that little fucking tiny buttons on it. So now I need to divide by n minus 1. There were 5 terms. So n minus 1 is 5 minus 1 is 4. I need to divide 374, sorry. 374 divided by 4 is, let's see, we got 9, 93.5. Can someone check that? That's good? Fuck yeah. Bam, in my head. Finally, we want to take the square root of that. This is probably like 9.7 or so. 9.8 maybe. So square root of 93.5. 9.6695. Maybe I'd go to 9.67. That's how you use square root by hand. Or standard deviation by hand. Square root by hand is not fucking pretty. Someone did it along with, we didn't always have calculators, but they had square root tables. That's some crackhead shit right there. I don't know if they just like kept writing smaller and smaller numbers and then squaring them and seeing if they got the number they wanted. Like I know they didn't even do decimals, they just did whole numbers at some point. All right, you guys ready for more? This last bit is on counting techniques and simple probability. So let's say you go out to dinner. Cruise ships do this kind of shit. They give you a variety, but it's a fixed number of varieties. Let's say you're on a cruise ship. And they say you have like a main course for dinner. The main course, you can choose chicken, steak, or fish. Then they might ask you for like an appetizer before that. So maybe soup, salad. Maybe they give you the option for bread and it's separate from super salad. So just work with me on this. They'd probably give you the bread anyways, but we're going to pretend it's a different option. Now let's say the side dish, they ask you to pick one. So maybe there's a baked potato. There's mashed potatoes. There's mixed veggies. Let's do a couple more. Corn on the cob. What?
Now you're making.
It's almost dinner time. Oh, rice. Rice is another one they like to offer. And finally, let's say they have a dessert. And you don't have a lot of options on dessert. You can have ice cream. Or you can have a piece of pie. So we want to figure out the total number of different plates that could be made. I am not going to draw this out, but I thought I'd show you a picture of it so you can see what it looks like. And it's not even for the same shit. You can do something like this where you have like the main choice is the first one. We've got chicken, steak, or fish. And then you do a little subcategory. This is soup, salad, or bread. And then you do another subcategory for each of those and do baked potato, like all that. You could make this giant tree. What the giant tree boils down to is take the total from each group, from each option, and multiply. So main course, what do we have for main course? I had chicken, steak, and fish. That's 3. The appetizer, I had soup, salad, and bread. That was also 3. The side dish, they probably would let you pick 2, but that doesn't make this, that's not a good example to use there. So you get 1. There were 5 different options here. And for dessert, there were only 2 options, ice cream or pie. So the total plates, total combinations of plates is 3 times 3 times 5 times 2. I tend to, if I want to avoid using the calculator, look for numbers that multiply to numbers that are easy to work with. 5 times 2 make 10. 3 times 3 make 9. And when I have a number that's multiplied by 10, I just add a 0 to the end. And so 9 times 10 is 90. So there are 90 different combinations.
And this is.
Yeah, is it counting up the different, this is a technique for counting, ooh, that was right, don't come up here. This is a way of counting up the different number of combinations, it's a technique for it. Okay, so sometimes like we want to look at things that we can't repeat. So like lotto, let's look at the lotto. Does anybody play the lotto? Does anyone done the lotto? How many balls are there in the lotto? Well, I know we get to pick 5. And then we have a super number, right? The super ball, super number. The mega, that's what it's called, the mega. Let me look up California lottery real quick. It's called Mega Millions, right? And how to play, there we go. There are 1 to 70 numbers. And then the mega is 1 to 25 for the mega. So if we want to do counting techniques for this, it's a little different. Because once I've got to pick 5 numbers. Let's say I pick the number 13. Can I pick 13 again? No. So maybe I'll go 7. I can't pick 7 again. We'll go with 69. We'll go with 49. And let's go with 47. So I picked 5 numbers. If I want to do the multiplying thing to figure out how many different options I have, how many different numbers did I have to choose from for the first number? How many different numbers were there? 70. Once I've picked the 13, how many are left to choose from? 69. As I keep picking a new number, this number goes down. So this number just keeps going down. I keep subtracting 1. Those are the total number of options I have to pick at that point. Then I get to the mega. And the mega, I can't have a repeat because it uses its own set of balls. So here I go and I don't have to worry about subtracting any numbers. I just go and look at how many mega numbers there were. There was 25 mega numbers. So the number of combinations of tickets is 70 times 69 times 68 times 67 times 66 times 25. Do what they say what that is here. No, so we will multiply that out. My calculator is telling me 3.63 times 10 to the 10. It's got some other numbers in there. After the decimal spot. So if I want to write that as a number, what I'm going to do is I'll put the 363 and I want to start moving the decimal spot 10 times. I'm going to move it that many times to the right. So I started here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And all the numbers I skipped that don't have anything there, I'm going to put in a 0. If I start putting in commas to make it readable, this says 36,300,000,000 combinations. Which means they're fucking flat out lying on this. Unless the how to play is wrong. 1 to 70 and then meg number between 1 and 25. Did anyone else get this? 3.63 times 10 to the 10? Did I fuck up my calculator?
Yeah.
You got it too? But they're trying to say it's 1 in 302 million. So they're full of shit. Yeah. X10 means is doing this thing right here, X10. Okay, so the probability, this is where the probability part comes in. Probability of winning with 1 ticket. Probability, we put the number that we have on top over the total options. If you have 1 ticket, you have 1 option of winning, and there are 36 billion combinations of tickets that they could actually draw. Which is 2.75 times 10 to the negative 11, which is probably, this is like 0.00000000. How many is that? 8, 9, and I'm gonna do a percent. That's your percent chance of winning the mega millions. So probability is options there are. Let's look at some smaller examples. Option we're looking for, or number of options we are looking for, over total number of options. And these two things combined, this counting technique and this probability kind of combine together pretty well when you're looking at things like craps, the dice game craps. In the dice game, perhaps you throw 2 dice. And you're trying to, there's certain odds associated with each thing. So like the probability, if we do like probability of rolling a 3. Ability of rolling a 3 on a 6-sided die. Those are the dice most people are familiar with. That's your Yahtzee dice. There's 6 sides. There are dice that have 4, there's 8, there's 10, there's 12, there's 20. Some crackhead made 100. I've seen 30. You go, okay, so like on a die, there's 1, 2, 3, 4, 5, 6. Those are my options on a die. Die is the single version for dice. Dice is plural for die. So I've got 6 total options, right? Only one of those is a 3. So that there's a 1. So the probability, and they use a P for it, probability that the roll equals 3. I'm going to make a fraction. I'm going to put the number that we have for the option we're looking for. There was only one that is a 3. There were 6 different outcomes. This is the same for any value on the die. All of them are 1 over 6. When you're rolling 2 dice, it's a little bit different. Each one can be 6 different options. This is like the main dish and the appetizer and shit like that. If we want to count the total number of outcomes, we're going to do our counting technique thing, multiply them. Each die individually has 6. So 6 times 6 is 36. There are 36 outcomes. If we want to add up the total on the dice, this is like me pretending I'm rolling 2 different dice. I can just add the row and the column. There is one combination that gives me a 2. The 1 and the 2 give me a 3, and this 1 and the 2 give me a 3. Let's say this is the red, we have a red die, and we have a blue die over here. So like we can clearly distinguish between them. The ways I can roll a 4, I can get a 3 and a 1 here, or that 3 and a 1 there, or I can roll a 2 and a 2. The ways I can get a 5, I can roll a 4 and a 1 here. So a red 1, a blue, or a red 4, a blue 1, or a red 1 and a blue 4 also gives me a 5. And we can do the same thing with the 2 and the 3. And you'll start noticing that they go along the diagonal. If you set it up like this, the numbers go along the diagonal and they just keep going up. So I'm going to speed it up a little bit by just doing the diagonal and adding 1 each time. Probably would have been quicker to just load this up on the fucking computer. And I very much want to make this line darker because these are the dice on the left. And those are the dice above. And the color combinations are the rolls. So let's look at the probability of getting a 3 now. A sum of 3. And then maybe do the sum of 7. In both cases, now if I add up all these up, I can see that I have 36 outcomes. If I add these up, 6, 12, 18, 24, 30, 36. So in each case, my fraction is going to have a denominator or a bottom of 36. Because that's the total. How many of them were 3s? Just 2 of them, right? How many of them were 7s? If I count up the diagonal there, it looks like there's 6 7s. So it's 2 out of 36 for the 3, it's 6 out of 36 for the 7. They will want you to reduce when you're doing this in the homework. And just see if like the upper number divides into the bottom number, do the factoring thing we've done before. This one reduces to 1 over 18. This reduces to 1 over 6. And it is 6 o'clock, so I really can't hold you any longer. So I'm going to go home and delete some of the stuff from the homework. And I'll have a practice exam ready for you guys. In the next 2 days, I will make an announcement and you'll be able to grab it from Canvas. Hey, Andrew.